Hi all, let's go through the anti-differentiating rational powers notes. As I mentioned before, we will be using exactly the same formula that we observed and identified for anti-differentiating powers of x. Here I have it. Integrating x to the r is x to the r plus 1 on r plus 1 is applicable for every rational number other than -1. Let's go through first few examples. Here I have x to the power 2/3. What I do is simply apply the formula that gives me x to the 2/3 plus 1 on 2/3 plus 1. Of course, these are fractions. Simply add them on and then leave the final answer. You can see the 5/3 is in the denominator, where you can bring the 3 to the numerator by flipping. That's simple calculation here, or rather simplification. And the answer is 3 on 5, x to the power 5/3 plus c. And of course, this type of problems, the second one, you have a bracket, and you probably remember when we did the differentiation, we did expand first and then applied the formula. So first you need to write this as an index form, x to the power half for the root x, and then expand the brackets. That gives you half plus 1 is a 1.5, which is 3/2. And then also half plus a quarter. In this case, when you multiply, it gives you 3/4. And then you simply apply the formula to get individual quantities for the antiderivatives. Then you have to put a plus c at the end. Well, underneath again, just the fraction addition with a whole number. And then you simplify it to 2/5 and 4/7 here. And the powers are respectively 5/2 and 7/4. Then we move on to this one, another type where we are going to have a look at a fraction. But you can't apply the formula to individual case. Rather, you need to split this nicely into two terms and then simplify each term using index laws. Then you get the power, which is for the x and here as well. Then you simply apply the formula. So you can't apply the formula or the rule unless you have x to the power r form. So you need to convert that as x to the r, just x to the r, not x to the r on x to the r form, not that one. Okay, so that's quite important. Then you apply the formula, then simplify, you get the answer. Well, the example 2 is the type where you need to do a bit of work first. Here we've been given dy by dx equals a times root x plus 1. Well, I don't know the a, but given the initial condition, I can find a. Simply substitution. So step 1 is you substitute to the derivative equation to find a first. Once you found that, you sub that back in and rewrite dy by dx. That means the derivative of y. How to find y? The intention is to find y in terms of x. Well, you need to integrate. When you integrate, you do have the powers where you apply the formula and you get a plus c at the end, of course. Well, now the y is in terms of x plus another constant. You've probably seen that earlier. The c has to be found if the initial condition is given. Well, we sub back again x value and the y value and then obtain the value for c. In this case, it becomes 10 on 3. Then you substitute this back again into the equation that you obtain for y in terms of x and a c, leaving the answer just in terms of x. Well, obviously this is a constant. So that's how you find the y in this type of problem. So these are sort of like questions you might get in the test or the examination. So it's good for you to go through these type of questions and get a good handle. So feel free to ask me questions. Happy to do a screencast. This is a sort of like a quick one which is derived from the previous lecture. So it's easier for you to go through. So I thought to do a little screencast here, just explaining the examples. Happy to assist with any other questions if you have. Until I find you again on another video lesson, bye for now.